So we are going to try and have a look at how we balance oxidation reduction reactions in basic conditions. So there's a very, very small difference between acidic and basic or alkaline conditions. And a lot of this is more or less the same. So the first thing I always do is I always assign oxidation numbers. So I do the easy ones, ions by themselves, oxygen, assuming there's no peroxides. So I have 2 oxygens times -2 is -4. So lead must be +4 to cancel out. Oxygen is -2. The overall is -1. So chlorine must be +1. Hydrogen is +1 in this case. So hydroxide's overall charge is -1, so 4 times -1 is -4. The overall charge is -2, so lead must be +2. So looking at this, I have my oxidation, lead +2 to lead +4. I have chlorine going from +1 to -1. So there's my reduction. So you have to have oxidation, you have to have reduction, they have to be separate. So I'm going to kind of work my way down a little bit and into the middle. I'm just going to write out my oxidation step. You got to watch your charges, because if you mess up your charges or forget your charges when you go to charge balance, it won't work. So we go through the same sequence, and when we get to the part that's different, we'll rewrite it, and hopefully that'll be enough. So we balance anything that's not oxygen or hydrogen. So lead is the only thing, it's good. Chlorine's the only thing, it's good. So that's part's done. That was easy. The next thing I'm going to do is add waters to balance the oxygens. I have 4 oxygen on this side, and I have 2 on this side, so I'm going to add 2 more. So I have 2 oxygen plus 2 oxygen is 4, which is balanced. I have 1 oxygen here and none on this side, so I'm going to add 1. So the next thing I do is I need to counter with hydrogen ions. So I have 4 hydrogen ions and I have 4 hydrogen ions, so I don't have to do anything to the top reaction. On the bottom reaction, I have 2 hydrogen atoms and none on this side. So what I'm going to do is I'm going to add 2 hydrogen ions. The definition of an acid is anything that dissolves in water and produces hydrogen ions. So the way it's written right now, this reaction is actually acidic. So how we're going to counter this, and what we're going to do, is we're going to add hydroxides anywhere we added hydrogen plus. So I added 2 hydrogen plus, so I'm going to add 2 hydroxides. But I can't just do it to one side, otherwise I've just unbalanced it. So I'm going to add it to both. Well, in this particular case, anytime I have hydroxides and hydrogen ions present, I'm going to get water. So I can get rid of those and just write it as 2H2O. The final thing, I guess we can rewrite these just so we are really clear on what's happening. So I'm just going to write a line. We don't always have to do this, but while we're trying to learn this, it probably makes sense to rewrite it. So really all I've done is I've written H2O out properly. So we have to charge balance. So I have -1 on this side, and on this side I have 2 times -1, -2 is -3, up here I have -2, that one's easy. And up here I have 0. So we add our electrons to balance. Got to make this the same as -2, which I've now done. And down here I've got to add electrons as well. Now, one of the issues that some students get hung up on is the fact that they think the charge on the sides need to match. So -2 and -3 need to match. And that's not true. The number of electrons need to match, and we can multiply the entire line by a coefficient to make it work, or both of them to make it work. But the actual charges on the reactant side don't need to match. The charge from reactant side to product side on the same half reaction do. So once I'm charge balanced, I'm just going to add them together. So 2 electrons and 2 electrons by necessity have to cancel out. So PbOH4 -2 plus 2H2O plus ClO -1 PbO2 plus 2H2O plus chloride plus H2O plus 2OH negative. So we start collecting water. So I have 1 water and 2 water. So I'm just going to change that and make it 3 and get rid of that. I have 2 water on this side and 3 on this side. So the 2 is going to take 2 away from both sides and change that to a 1. So I have lead hydroxide ion, ClO -1, PbO2. So we can just write this out hopefully and we're good now. PbOH 4 -2 plus ClO -1 gives me PbO2 plus H2O plus chloride plus 2OH. And if we're being picky, we should probably write our states in. Any ions are going to be aqueous. Solid. Water is always liquid. We write it out, and that's how we do it. And you can see that in a basic balance, we always have a hydroxide that is showing, or usually at least we do. That's how we do basic balance.